Welcome, Mindsetters, to this another live session for grade 12. Guys, I hope you guys are nice and ready because we're going to be doing a lot today. Ms. Heather, what are we going to be doing today?
We're actually going to try and do as much revision as possible because the guys, you are ready to start exams. So we're going to, E.T. and I, we're going to tag team. We're going to try and do as many sections as we can, some sequences, some inverses, some trig, some finance, and if we get time, then some graph interpretation as well.
All right, awesome. So while the lovely Heather walks across,
Do
guys, you know the drill. Make sure you get to me on the page, www.facebook.com/learn extra. Make sure you get chatting to me if you're lost anywhere, if you need help. Make sure you get chatting to me because I'm also going to be giving away these books. Make sure you want to get one of these. You really want to get one of these. These are so helpful. I've been going through them myself as well. They are awesome. And guys, as always, I'm giving away this Casio calculator and this labeler. So make sure you get chatting because the more you chat and the more you help out, the bigger chances you are of winning one of these. And I want to send a quick shout out to Liberty. Thank you for sponsoring. And on that note, I'm going to hand over to Miss Heather. Heather, take it away.
Great. Okay, so guys, what we're going to start with is some questions from a paper that most of you have not seen. It comes from the February-March supplementary paper. I know that they actually publish the end-of-year papers quite readily, but the SUPs, they sometimes don't publish. So hopefully these are going to be some fresh questions for you. I might go a little bit fast, all right? So if I am, please tell Ty, because what we really want to do is get through as much as we possibly can. So I'm not going to labor too many points. Okay. So the first question is, consider the geometric sequence 4, -2, 1. Determine the next term of the sequence. Now, if you are so lucky to get something so easy, let's just make sure that we can start it off, and we know that if we're actually going from there to there and there to there, we need to find a common ratio. So I know that my common ratio is going to be my second term, which is -2, over my first term, which is 4. Or, of course, I could have said my third term, which is 1, over my second term, which is -2. And you can see that those are equivalent ratios. So that is my common ratio. Therefore, my next term is clearly going to just be, I'm going to take 1 and times it by my common ratio, so my next term would be -1/2. If you got that, that's 2 marks in the bag. Well done. Let's keep going. Right, the next question says, determine n if the nth term is 1/64. So remember, we've got this sequence, and somewhere down here is going to be 1/64, and we want to know where. Okay, so I think that maybe we're going to go to yellow for this one. So my term n is 1/64. Now remember that my first term was a 4. My common ratio we have worked out is -1/2. And so I'm sure you can all have a look at the formula sheet. We know that the nth term of a geometric sequence or series is AR to the n minus 1. And we can set that equal to 1/64. Now notice that what we have here is something with 3 variables, okay? A, R, and N. But we know A, we can plug that in, it's a 4. We know R, it is definitely -1/2, and that is to the exponent n minus 1, and that comes to 1/64. Now, when my candidates do mathematics, I like to say to them, what are you expecting? Can you see that every odd term is a positive number, all right? So the odd is positive, the even term is negative. The odd is positive, the even is negative. So therefore, if I'm trying to find out which term is 1/64, all right, I'm thinking, all right, that it's a positive, so I'm thinking that I'm expecting n to be odd. All right. You're not getting marks for that. It's just something that's what you're expecting, so you can check it at the end, see if your gut feel was correct. Okay, how do we solve something like this? Now, I know that some of you really battle with exponents, but clearly what I'm going to do here is I'm going to try and make it nice by dividing by 4 on that side, which means I've actually times by 1/4. So I'm going to times that one by 1/4 as well. And so now I am left with negative a half to the exponent n minus 1 is equal to. Now, of course, I can take 64 and multiply it up, and I'm going to get 64 times 4 is 256, all right? But what I might be more interested in doing is thinking about 256 as being 2 to the power of what? Okay, so that's what I'm thinking. Now, I know 64. 64 is 2 to the 6, and I know that 4 is 2 to the 2, so that's why I'm thinking that 2 to the 8 is 256. Okay, right, so let's have a look. I've got negative a half to the n minus 1 is equal to 1 over 256. Well, 256 we've decided is 2 to the 8. Right, now we've got a problem because this thing here is minus a half and this thing here is positive a half. But remember that because this is an even power, I could actually say that this is the same as negative a half to the 8. All right? Because that is the same as positive a half to the 8. Only because it's an even power. We can't do that if it's an odd power. All right? So guys, you can see how cool this is. It's fallen into place. I'm actually going to get that my n minus 1, let's show you here, is going to be the same as there. And so n minus 1 is equal to 8. So n is 9. Now remember I said gut feel, it's got to be an odd number. And I've answered the question, determine n if the nth term is 1 in 64. 1 over 64, I've got that it's the 9th term. Right, same question. Calculate the sum to infinity of the series 4 minus 2 plus 1. Now remember that we can only ever sum to infinity if we've got a series that is converging. So, why is this series converging? Well, can you see that our r value we got to be negative a half, and when our r value lies between negative 1 and 1, each of our terms is getting smaller and they are converging. The terms, okay, are converging on 0. And so that means that we can sum to infinity. All right. The sum to infinity on your formula sheets is going to be a over 1 minus r. So according to my given series, if I take a, it is a 4. Over 1 subtract, my r value is negative a half. And so this is just a matter of calculator. So 1 add a half is 3 over 2. And if we tip and times that, we're just going to get 8 over 3. Now, what does that 8 over 3 mean? Well, it means that I can add up 100 terms or 1,000 terms or 2,000 terms, and the answer will never equal 8 over 3, but its limit will be 8 over 3. So it'll never get more than that. But as I add each term, it's going to get closer and closer to 8 over 3. Okay. In the same paper, a nice little sneak question. It was out of 3 marks. It says, if x is a real number, and it's even highlighted in capitals, show that the following sequence cannot be geometric. Okay, so we've got 3 random terms, 1, x plus 1, x minus 3, and they say show that it cannot be geometric. Now, the only thing I know to do with a geometric is if it was geometric, all right, then I would definitely be able to make a common ratio. So I would know that x plus 1 divided by 1, term 2 over term 1, would be equivalent to x minus 3 over x plus 1. Right, so if it were geometric, I would be able to do that. Multiplying up, I would get x plus 1 squared would equal x minus 3. All right, you know what to do with that. Of course you do. We're going to just distribute. We're going to get x squared plus 2x plus 1 is equal to x minus 3. Right, we've done enough of these to know that we're going to have to just bring everything across to the left-hand side, which gives me that. Right, now we're trying to solve for x. Now guys, if you have a look at this, all right, and you try and factorize it, you need factors of 4 to give you 1. Now, no matter how hard you try, that's not going to work, okay? Now, even if you try the formula, you're going to get minus b's amount plus or minus the root of b squared, which is 1, minus 4 times a, which is 1, times c over twice a. Now, I don't even have to do anything more, because I'm sure that what you've recognized is that this thing here, all right, which is actually the value for b squared minus 4ac, all right, has actually landed up being a negative. And we know that we cannot square root a negative number in the real number world, and so therefore there's no real roots. How cool is that? So they've kind of brought in a little bit of solution of equations into the middle of a geometric sequence. All right. Now, before I came on the show, I was given a question, and Pumelelo, this is yours, it's for you. Pumelelo, sorry, there we go. She gave us the question 2x, x squared, and a half x cubed. And I don't know where she got the question, but the actual question is, find the nth term. Right, so this is just for you. Here we go. Having a look at the actual sequence, I think that all of us can see that it's definitely behaving like a geometric sequence, okay? And if I take term 2 and divide it by term 1, I'm going to get x squared over 2x. One of the x's cancel and I get left with x over 2. Now, if I had to do the other term as well, term 3 over term 2, you can see that I'm going to get a half x cubed over x squared, and that is also going to give me x over 2. So I have verified that my r value is x over 2. So if I'm looking for term n, I must be aware that that's going to always be my formula no matter what. So according to my given sequence, all right, remember my first term was 2x, so my a value is 2x. My r value, according to what I've worked out, is x over 2, but that is to the exponent n minus 1. Now, if you left your answer like that, I suspect that they would take off a mark, because you can see there that that can be simplified, okay? So I'm going to just leave this as 2x, and this is going to become x to the n minus 1, and on the denominator, that's 2 to the n minus 1. Now I'm just going to tidy it up. So I'm going to go for my x's first. Notice this is x to the 1. It's being multiplied by x to the n minus 1. And so remember, we add our exponents when we multiply like bases. So we're going to get a 1 and an n minus 1. And then as far as my 2's are concerned, I think I'm actually going to do the 2's on the denominator. So I've got a 2 to the n minus 1, and I'm going to divide by this 2, which is 2 to the 1 minus 1. And so I'm going to get x to the n, tidying that up, and 2 to the n minus 2. So, Pumelelo, I hope you're happy with that, and then we can move on. Okay, I'm going to go crazily through the next couple of slides just to get to the next one that I want to do with you. And this is to do with inverse functions and graphs. All right. One of the things that I actually want to point out to you is that logs as a topic normally gets examined in the section of graphing. Okay, it's not so much the manipulation of logs or the evaluation of logs, but they really do want to see how you cope with the log graph as an inverse of the exponential graph. Okay, so the first thing that we get given is that f of x is 3 to the x. Determine an equation for the inverse in the form f's inverse of x equals. Now, guys, I know that all of you are aware that when we take a graph and we want its inverse, we switch the x's and the y's. So what you would do first is you would first say x is equal to 3 to the y. Now, can you see that the y is the thing that you're looking for, but it's floating at the moment, and so the only way that we can actually bring that y down is with a process that we've learned called logging both sides. So if you log the left and you log the right, we land up getting that the log of x, and you know as a law we can bring the y to the front, and so it becomes y log 3, and finally using our log laws, dividing by log of 3, we would get log of x over log of 3. Okay? Now, some of you would have been able to go straight to the answer that the inverse is log to the base 3 of x, and that would have been absolutely cool, and you would have got your 2 marks. No problem. Right, next question. Ty, anybody moaning that I'm going too quick?
No.
Okay, so I can keep up the pace. All right, sketch the graphs of f and its inverse, showing clearly all intercepts with the axes. Okay, so let's just get ourselves an axis quickly. All right, and then let's go for the minimum amount of information. So we want to sketch y equals 3 to the x. Now, I'm hoping, guys, that most of you would go and use your table function, and you would use something like -1, 0, and 1. And when you plotted this graph, it would look something like that, and definitely this would be the point 0 with 1. Again, I'm not going to spend too much time laboring it because I think that you guys do know this. Right, our inverse is log to the base 3 of x. Now remember, the inverse is just going to be the actual reflection in the line y equals x. So there's my line y equals x, and if I take the reflection, this point reflects to there and becomes the point 1, 0, and then the log graph looks something like that. So for example, where on this graph we've got the point 1, 3, on this graph we've got the point 3, 1. And of course, I'm just going to give that as the inverse, and I'm going to give, whoopsie, that decided to move, going to give that as f of x. So sketch the graphs clearly showing all intercepts with the axes. That's 4 marks in the bag. Right, next question. Says, write down the domain of the inverse. Now let's just keep in mind what our inverse looked like. Okay? Domain, remember domain is your x values, and range is your y. Now, the only way that I get my kids to remember this is D comes before R in the alphabet, and X comes before Y in the alphabet. So it kind of links up. So what are the X values that we've used in the inverse? Well, you can see that the graph is exclusively to the right of the Y axis, and so therefore my domain is going to be X element of real, but x greater than 0. Right, next question. For which values of x will f of x times its own inverse be less than or equal to 0? Now again, I need to just bring this guy back so that we can see in essence what are they talking about. They want the y value on the one graph times the y value on the other graph to be less than or equal to 0. Now, I know that if I'm coming with x values that are negative, can you see that the f of x graph is defined? The other graph isn't even defined. Okay? Then I get to the y-axis, and this graph is still not defined. But if I take anything over here, any x value over here, can you see that the y value on the yellow graph and the y value on the purple graph, here the y values are positive, and here the y values are negative. So it's literally going to be, okay, I hope that my mucky graph, it's literally going to be for this part, my function's inverse is negative, and for this piece, my function's inverse is positive. Anything to the right of that, I'm going to have a positive times a positive, which is not good enough. So literally, it is going to be 4 x values that lie between 0, not included, because the inverse wasn't even defined then, all the way up to and including 1. Because notice that where this was 1, okay, this was the point 1, 0. So when I multiplied the values when x was a 1, I would have got it equal to 0. The rest of the time it would have been less than. Okay, write down the range of a graph called 3 to the minus x minus 4. Now guys, I don't know about you, but I would actually think about this just carefully before putting down my pen and answering. I would say, okay, what does 3 to the minus x look like? Well, we know that what the minus x does is it actually reflects it in the y-axis. Then, if we want to take 3 to the minus x, subtract 4, you see what is going to happen here is it's just going to take that same graph and drop it down by 4 units. So where this one was cutting at 1, this one is going to cut at minus 3. Okay? And now it says, write down the range of that graph. Now remember that this graph was asymptotic to the x-axis. Okay? So this one has been dropped down by 4 units. So this one is going to be asymptotic to the line y equals minus 4. Okay, so the line y equals minus 4 is going to be an asymptote. So now we want the range. So where is this exponential graph lying? Can you see that it's going to be lying y above minus 4? Not equal to minus 4. It will never ever touch that line minus 4, just like the original never ever touched the x-axis. Okay, hopefully that explanation is clear. And lastly, write down an equation for g. If the graph of g is the image of the graph of f, after f has been translated 2 units to the right, so let's just take our f of x, which is this guy. We want to translate it 2 units to the right, okay? And then we want to reflect it about the x-axis, across the x-axis. Okay, so keep your wits about you. How do we move things to the left or the right? Well, it's got to be part of the x. Okay, we're not moving it up or down. That would be to the y. We're moving it to the x. Now, if we want to move it 2 to the right, we know that it's going to have to be x minus 2. Okay, would move it to the right. Now we want to reflect it across the x-axis. And you know that if you want to reflect something across the x-axis, what happens to a point? Okay, so let's say the point 2, 3. What does it become? It becomes 2 minus 3. So the y value becomes negative. So that means that I have to now put a negative in front there. So g of x is the negative of 3 to the x minus 2. Ty, we're done.
Yes, we've got a couple of people who actually wanted to find out.
Yeah.
they're having a couple of different issues with asymptotes and understanding how those graphs work, if I'm not mistaken. Let me see, what else can I find here? Okay, I think for now, we're just going to take a little bit of an ad break, and then we'll get back to those guys when we get back.
Cool. Even after ET's presented, that's also cool.
Yes, that'll be awesome.
Okay, no problem.
So guys, make sure you keep getting those questions in. I'm seeing a lot of you guys who are following through. Yes, I understand, and yes, I understand some of you just now have popped up and saying she's a bit fast, but we're going to address that. There's just a lot that we have to cover. So guys, we're going to see you after this break. Welcome back, Mindsetters. I hope you had a nice little break, and you're going to notice just now we did a little bit of a magic trick. But Mr. E.T. is now in the building, and guys is going to be taking you through this next section. Guys, make sure you have your pens and pads out and you guys are making notes. And guys, keep posting, because I am still trying to give these away. Make sure that you guys, make sure, actually, yeah, I still have these books to give away. So guys, these are so awesome. And I'm seeing so many of you Mindsetters on the page. Guys, I'm loving it. And guys, don't forget, yes, before I hand it over, make sure that, guys, grade 12s, you guys have tuned in from the 2nd of July to the 6th of July, because that's when your winter school sessions start. And also, we'll be doing sessions on Saturdays from now on for you guys to get that extra revision to make sure that you guys can put that pass mark up here for those matric results. But for now, I'm actually going to hand over to Mr. E.T. Mr. E.T., take it away.
Oh, thank you, Ty. I'm going to move on from where she left.
Where she left off? Okay, where I can actually find it is actually right here.
Right.
All right. This is where
Thanks a lot.
No problem.
Good.
See, it's always handy that I also know what to do with these board things. But yeah, Mr. E.T., take it away.
All right. So, yes, Heather did say that there's a lot that we have to cover. And I had to pick and choose as well. I decided I'm going to do a bit of trigonometry. And I'm starting off with a question here that says, if sine 61 is equal to square root of p, determine the following in terms of p. And there's a few of them. The first one says sine 241. Right? Now you'll have to remember all your reduction formulas based on the horizontal line, the 180 degrees and the 360 degrees. All right. So in this case, we will take it from here. We will say that is actually equal to sine of 180 degrees plus 61. All right, so the intention is to reduce all these non-acute angles into, acute angles. In this case, we are intending to write sine of 61, but the question we are going to ask ourselves is, what is the sign of this ratio in this quadrant? In which quadrant are we? We're in the third quadrant. So most of you will remember that all ratios are positive in the first quadrant. Only sine is positive in the second quadrant. Tangent is the only one that is positive in the third quadrant. Then finally cosine, what I used to call all students take coffee. All right, so yes, we asked the question, how is this ratio in that quadrant, in the third quadrant? It's only positive here and there, therefore it's negative over there. Then you assign a negative to that sine 61. And yes, we know what is sine 61. It is square root of p. So which means our answer is minus square root of p. There is your answer to the first question. The second question, right away, it says cos 61. And here we have to remember the square relation. The square relation, if I can write it here, it says sine squared of an angle plus cos squared of an angle equals to 1. And you can rearrange that. For instance, in this case, we want cosine of an angle. therefore, knowing sine of an angle. Therefore, we can rearrange this thing so that we have got cos squared theta equals to 1 minus sine squared theta. And to find our cos theta, which is what we are looking for here, we'll simply square root both sides, and we end up with cos of theta equals to square root of 1 minus sine squared theta. Okay, so then we have an idea what we should be doing with that cos 61. It's simply going to be equals to square root of 1 minus sine squared 61 again. Okay, we just write that. 61 degrees. Okay, and our answer simply becomes square root of 1 minus. Now, our sine 61 is square root of p. Now we have to square it, and if we square it, it's simply going to be p. All right, so that becomes our answer there. All right, just a reminder quickly, let me see if I don't leave anything out. Yes, we are dealing with an angle that is in the first quadrant. That's the 61. So I was worried that we may have to pick on the negative value there. But we don't have to, because all the ratios are positive in the first quadrant. So this is the right answer that we could come to. All right. So the next one, you know, it's more like I think it's very much the same as the one that comes after this, but I prefer to take the next one, which is more of a challenge. It's going to come out with it's going to test your knowledge of double angles. All right. So what you have here, if you remember your compound angles, not double angles, compound angles, it's going to be cos of, let's say, beta minus alpha. The rule says you then have cos beta, cos alpha, plus sine beta, sine alpha. Okay, so we're simply going to apply that rule. And in this case, 73 will be our beta, and 15 will be our alpha. If we look at it in that way, we end up with cosine. Okay, from that step, we just have cosine of 73 minus 15. Allow me to create space at the bottom here. Let's see. All right. If we continue from there, this is now cos of 58 degrees. This doesn't look like it's related to our sine 61, which we started with. But if you look closely, you realize that 61 and 29, they add up to 90. They are complementary. In this case, we don't have 29 here, but we have twice that. 58 is 2 times 29. So we could carry on and say this means we've got cos of 2 times 29 degrees. All right? And if we go back to the double angles, this could be written as what is that? 1 minus 2 sine squared of 29 degrees. We are right at the end of the question, because we know what is. Let's go up here. All right. Oh, we actually have. We had. If I go back here. We had sine 61, and we need to basically use the other. Okay, there are actually 3 forms of this equation, the double angle. So in this case, if I can just erase this for now, because I will use the the other one which says 2 cos squared 29 degrees minus 1. The reason why I use that is because I know that sine of 61 is complementary. 61 is complementary with 29. So where I have cos 29, basically it's the same as sine 61. All right? So I can actually say this is 2 sine squared 61 degrees minus 1. And that becomes your answer to this equation. To this question. That's this is squared, so it means you have got p, because square root of p times square root of p is equal to p. So that's minus 1. That is the answer to that question. Hopefully there are no questions about this one.
Not as yet. I'm still loading the page, so not yet. As soon as I do find one, I will let you know.
All right. Okay. So I skipped a few questions here. I think I'll take an identity. If I can just erase this to create some space here. All right.
All right.
Okay.
So guys, I cannot stress enough, make sure you get on the page and get posting, because I still have to give these away. I've got so many, I don't know what to do with them. Besides, give them away to you guys. So guys, make sure you get friends and whatever you need to do, get study mates, all this stuff, organize study groups and get on the page and get chatting to us. Make sure you guys use this page, because it is for you guys. But for me, I'm going to hand back to Mr. Iti. Mr. Iti, take it away.
Yes. I'm now going to choose one of these questions where it's basically an identity. You have to prove the left-hand side is equal to the right-hand side. All right, so the question we have here says that fraction, take away that fraction equals to what you see on the right-hand side. So what I see immediately here is that the denominator is not the same. That being the case, it means I must make a plan, and all I can do is, okay, take the left-hand side, and that is going to be, all right, let's write cos of x plus sine of x. All right. Now, I need to have these denominators to be the same. And to do that, I will have to multiply this fraction. Notice that I call them fractions because that's the way you should learn to deal with fractions. So on this side, I can multiply this by that. So all I'm short of here is cos of x plus sine of x. And I must put it on top as well. Cos of x plus sine of x. That's just one part of it. And if we subtract that, create some space there, then I've got cos x minus sine x, all divided by cos x plus sine x. And again, I want to create a situation where the denominators are the same. So I will have to use the negative 1 now. Cos x minus sine x, cos x minus sine x. So if you look at these two terms of this left-hand side, now they have a common denominator. And it means, therefore, I can basically write them with one long division line. And when I look at what is happening in the denominator, it's actually two factors, and it's the difference between two squares. All right, so that is cos squared x minus sine squared x. Okay, at the top, now what I have is, okay, if you look at that, it's just cos squared x plus, okay, 2 cos x sine x plus sine squared x. Okay, and This is a long line. On the second part of this thing, you've got minus, and of course, this, let me just put a bracket so that we don't confuse this with the minus that is outside. So what you see here now is there is a negative outside, but in that you've got cos squared x minus 2 sine x cos x plus sine squared x. Okay, that's what you have on the right-hand side. Now I've got that square bracket, and everything inside the bracket is going to be affected by the minus. Therefore, what you will see immediately is that the cos squared will fall out. What else will fall out? Okay, I think the sine square will also fall out. So what you're left with is 2 cos x sine x, and that one is going to turn into a positive. Again, you've got, basically, if you add those two, you've got 4. All right, that becomes 4 cos x sine x. And all of that is divided by cos squared x minus sine squared x. Right. Let's not lose track. We want to show that we are going to end up with 2 tan of x. All right. So what you have at the bottom, therefore, is, let's go. All right. This is for, what you see at the bottom can be turned around into, what do you call it again? Yeah, let's see, the double angle formula there. Okay. So basically this becomes 2, what is this now? That's 4 at the top. X sine x, right? Okay. I think I want to write what is on the right hand side. Yeah, 2 tan 2x. So 2 tan 2x. Okay, that's what I want to end up with. So I mustn't lose track of that. So what I have here already has got a part of sine that I'll require for this tan, because if you look at it, it's basically 2 sine x, sine 2x, yes, over cos 2x. Oh yes, that's actually where the answer comes out. This is 2 multiplied by, when you have 2 sine x cos x, basically that is your sine 2x, and this one at the bottom is already cos 2x. So at the end, you've got 2, and this is sine 2x over cos 2x, which is 2 tan 2x. Okay. That wraps up the trigonometry part.
Alrighty.
Like I said, we had to pick and choose. I mean, there's a lot we could do.
No problem, no problem. My whole thing is that as long as the guys are understanding and you guys are posting on the page and letting me know where you guys are going wrong, make sure you keep posting. I'm seeing a couple of you on the page and I'm liking, but right now we're actually going to take a quick ad break and we'll see you after this. Welcome back, Mindsetters. I hope you had a nice little break. Make sure you have your pens and pads out and you guys are making notes. And guys, if you see anyone on the page who's having problems, please help out where you can. Because the problem is that right now there's so much stuff that we're going through, we won't always be able to get to every question. So guys, make sure you help each other out. And guys, for those who are helping out, you could win one of these, so it is worth it to try. So guys, I'm going to hand over to the lovely Heather now, who's back in the studio. So Heather, take it away.
Thanks, Ty. Okay, guys, we're going to go into the last session, and I've decided to take a finance question because I know that that's the kind of section that a lot of the candidates battle with. It's a 4-part question, so let's get to it. Lorata wants to purchase a house that costs $850,000. She is required to pay a 12% deposit, and she will borrow the balance from the bank. Calculate the amount that Lorata must borrow from the bank. Now, obviously, this is a very easy part of the question. So, of course, we are looking at, first of all, how much is she talking about? Well, it's definitely going to be 850,000. And she's got to put down a 12% deposit. So I'm going to multiply that by 0.12. And using my calculator, we're going to definitely get, there we go, we're going to get 850,000. Just put in enough noughts, and we're going to times by 0.12. And we're going to get that that's 102,000, okay? 102,000, and the problem is that this keeps on disappearing, but that's not a problem. Okay, so what she therefore has to loan from the bank is 850,000. All right, subtract her 102,000, and that we can do without the calculator, and we're going to get 748,000. Right, so that's what she needs from the bank. So the next question that they ask is, the bank charges interest at 9% per annum, compounded monthly, on the loan amount. Lerato works out that the loan will carry an effective interest rate of 9.6. So in other words, the bank have come along and said that the nominal rate, all right, is going to be 9% per annum compounded monthly. All right? So that's my 9% compounded monthly. So she works out that the effective rate, all right, so if the bank manager had just come out once a year, in other words, per annum, once a year annually, she says that the effective rate is actually 9.6%. Okay? And the question is she correct or is she wrong? Is her calculation correct or not? Now, obviously, that is a yes or no answer, but you have to justify with appropriate calculations. So here, guys, what we really, really need to be able to do is we need to be able to calculate from an effective rate and a nominal rate. So we have a formula which says that 1 plus my effective interest rate, actually that is to the power of 1, and this is actually over 1 because it's one payment in the year and it's over one time period, okay? In other words, a year. We know that that is equal to 1 plus I to the m over m, all to the power of m. Now that's a really fancy formula, but how it works is the following. I'm trying to find my effective rate. So I'm going to have 1 plus I effective is equal to 1 plus. Now she was told that it was 9% per annum compounded monthly, so it's divided by 12, and we are going to raise that to the power of 12 because the bank manager would have come out 12 times in the year. Right. So now, guys, unfortunately, it's off to the calculator, so off we go. So we are going to take our right-hand side, which is going to be 1 plus 0.09 divided by 12. I could have used the fraction, but I just didn't. All right, and that is to the exponent of 12 equals. And that gives me 1,0938. 1,0938. All right, with a couple more decimal places as well. So if I'm wanting my effective interest rate, I'm going to subtract my 1, which is going to give me 0,0938. And of course, my rate, for my actual rate, is going to be, I'm going to times this guy by 100, which moves my decimal place twice. So that's going to be 9.38% per annum effective. So let's go back to the question. The question actually said that Lerato worked it out to be an effective interest rate of 9.6%. Is she correct? No, she's definitely not. So we would therefore say, no, she is wrong. Okay, so somewhere along the line, her calculator work was a little bit dodgy. Okay, next question says, she takes out a loan from the bank for the balance of the purchase price. Now remember, her balance of the purchase price was 748,000, and she was going to do a loan for this amount. Okay? She agrees to pay it back over 20 years. All right, her repayments start 1 month after her loan is granted. Determine her monthly installment if interest is charged at her 9% per annum, compounded monthly. Okay, so they're making you use her correct one, not the wrong one that she worked out. Now, guys, I don't know about you, but there are 2 different ways for us to work this one out. So I'm going to show you both, but I'm not going to do all the calculator work, okay? I'm just going to spend my time working on the 2 different ways to work it out. I find that I cannot do any of these problems if I do not have a timeline. So I do know that she is taking out or getting from the bank 748,000, all right? And she is going to repay this over 20 years, which is 240 months. Right, now, it all depends where Lerato stands. If Lerato stands here, then her 748,000 is regarded as a present value. Okay? Now, if we're going to regard it as a present value, then the formula that we are going to use is that 748,000 is equal to X, and then we have 1 minus 1 plus our interest rate to the negative 240 over our 0,09 over 12. Now, if she is standing at the present value, it means that all of these X payments that she is making, all right, all have to actually be brought back and stripped of their interest, okay? And that's why it is a negative exponent. Now, to work this out on your calculator, you're going to take your 748,000, you're going to multiply it up by 0,09 over 12, and then you're going to divide it by this ghastly thing. Okay, and I'm not going to spend time actually working that out, because I know that my answer is 6729,95. Okay, now that's the one way that you can do the question. Now, some teachers avoid that present value formula like the plague. And so they would rather take the 748,000, which is now, and take that all the way to 20 years. So what they do is they treat it as a future value. And so they say that the 748,000 over the 20 years would have to grow with an interest rate of 0,09 over 12 for 20 years. So that would actually be the value of the 748,000. But Lerato is actually paying that off at X amount per month, and so she is going to have 1 plus 0,09 over 12. She's going to make 240 payments, all right? And her interest is 0,09 over 12. Now, you can see that both of the formulae involve heavy calculator work, but it's just getting the stuff into the right place that's really the most important. The one formula, if we just revise, the one formula is taken as a present value, so the 748 is paid off at X a month, and all of those X amounts need to get stripped of the interest that they've earned, which is why it's a negative exponent. And the alternative is to actually treat it as a future value. So in other words, to grow the 748,000 for the 20 years, and then for Lerato to pay it back as if she was investing. Okay, so guys, I hope I haven't gone too quickly with that. Obviously, the calculator work you're going to work out for yourself, but we've really tried to do as much as we can, Ty, in the time that we've had.
It's completely understandable. Like I'm seeing, like I know, I can see there's guys who are out there, but one thing that's great about this is that people have been helping out, which is awesome, awesome, awesome. So guys, I always encourage you guys to help each other out and make sure you talk on the page, because yes, you could win one of these. And I will be scanning up and down today's page to make sure I find the people who really deserve this, and those guys who really need access to these resources. Make sure, guys, you keep chatting. Chat, 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 chat. I cannot stress it enough. It is so, so important for your mindset is to get in tune with each other and know each other and actually help each other out, because I want to give away a lot more of these books. But for now, I'm going to sign off, and we'll see you after the holidays when you see you next time. Cheers.